Good morning friends, I am back again with one video lecture on the topic solution of the system of linear equation. Now we will discuss solution of the system of linear equation with one interesting example. Now example is determine for what values of lambda and mu the system of equation x plus y plus z is equal to 6, x plus 2 times y plus 3 times z is equal to 10 and x plus 2 times y plus lambda times z is equal to mu has number 1 no solution, number 2 unique solution and number 3 infinite solution. Now solution, first we write the matrix form of the given system. The matrix form is Ax is equal to B, where A is the coefficient matrix. Here A is equal to, now coefficient of xyz in the first equation, the first row be the 1, 1, 1. Now coefficient of xyz in the second equation, the answer is 1, 2, 3. Therefore we write here 1, 2 and 3. Now coefficient of xyz in third equation, answer is 1, 2 and lambda. So this is the third row of the coefficient matrix A. Now next part be the x be the variable column matrix. Now here variables are x, y, z. X, y and z. Now this B be the constant column matrix. So here answer is 6, 10 and mu. Therefore augmented matrix C is equal to matrix A and matrix B. Therefore this C is equal to matrix A. A means this matrix, coefficient matrix 1, 1, 1, 1, 2, 3 and 1, 2 lambda. Now matrix B, and matrix B be the this column matrix 6, 10 and this last element is mu. To find the rank C, we convert this matrix C into echelon form. Then we count the number of non-zero rows in the echelon form of C. We get the rank of the matrix C. Echelon form means we convert all the elements below the diagonals are 0. Now here this 1 be the first diagonal element. Now we convert all the elements below these elements are 0, means we convert here 0, here 0, means R2 changes, R2 minus R1. Similarly R3 changes, R3 minus R1. Now this new matrix is equivalent to old. Now first row as it is 1, 1, 1 and 6. Now R2 changes 1 minus 1, 0, 2 minus 1, 1, 3 minus 1, 2, 10 minus 6, answer is 4. Now R3 changes, R3 minus R1, 1 minus 1, 0, 2 minus 1, 1, lambda minus 1, answer is lambda minus 1 and mu minus 6, mu minus 6. Now this one be the diagonal elements in the second row. We convert here 0 by using this second diagonal elements. That is R3 changes, R3 minus R2. Now new matrix is equivalent to old. First row as it is 1, 1, 1, 6. Second row as it is 0, 1, 2, 4. Now R3 changes R3 minus R2, the 0 minus 0, 0, 1 minus 1, 0, lambda minus 1 minus 2, answer is lambda minus 3, mu minus 6 minus 4, answer is mu minus 10. Now this is the echelon form of the matrix C. In this problem we determine lambda and mu so that the given system has number 1 no solution, number 2 unique solution and number 3 infinite solution. Now we determine lambda and mu so that the given system have no solution. Now number 1, no solution. Now no solution means system is consistent, that means rank A not equal to rank C. Now if this lambda minus 3 is equal to 0 and this mu minus 10 not equal to 0, then rank A, this is the echelon form of A, and if lambda minus 3 is 0, then this row is 0 in the echelon form of A, and therefore number of non-zero rows in the echelon form of A is 1 and 2, and therefore rank A is equal to 2. And rank C, then rank C means number of non-zero rows in the echelon form of C. Now this mu minus 10 not equal to 0, so therefore this last row be the non-zero row for the echelon form of C, and therefore number of non-zero rows in the echelon form of C, answer is 1, 2 and 3, therefore rank C is equal to 3. Now here rank A is equal to 2 and rank C is equal to 3, so therefore rank A not equal to rank C, and therefore the system is inconsistent, and therefore the system has no solution. When lambda minus 3 equal to 0, that is lambda is equal to 3 and mu minus 10 not equal to 0, that means mu not equal to 10, means mu is other than 10. Now we determine lambda and mu so that the given system have unique solution. Now unique solution means rank A is equal to rank C is equal to number of variables. Now here n means number of variables and here number of variables is equal to 3. Now if lambda minus 3 not equal to 0, then this is the non-zero row for the echelon form of A and echelon form of C also, and this mu minus 10 means mu may have any value. Then rank A is equal to 3 because this lambda minus 3 is non-zero, then number of non-zero rows in the echelon form of A is 1, 2 and 3, and rank C is equal to 3 because again number of non-zero rows in the echelon form of C is 1, 2 and 3 because this is the non-zero element, and therefore rank A is equal to rank C is equal to R is equal to 3, and here number of variables be the 3, and therefore this R is equal to n. Therefore the given system has unique solution when lambda minus 3 not equal to 0 means lambda not equal to 3 and mu may have any value. Now last case means infinite solution. Infinite solution means rank is less than number of variables. Now here number of variables be the 3. Now if this lambda minus 3 is equal to 0 and this mu minus 10 is equal to 0, that is this lambda is equal to 3 and this mu is equal to 10, then rank A means number of non-zero rows in the echelon form of A, the answer is 1 and 2. Similarly rank C, again number of non-zero rows in the echelon form of C, answer is 1 and 2 because this is the 0 row in the echelon form of A and in the echelon form of C. Therefore rank C is also 2, and this is the R. Now here n be the 3 and therefore R is less than n. Now R is less than n, therefore the system has infinite solution. Hope all of you have understood this problem. In the upcoming lecture, we will solve more problems based on the solution of the system of linear equations. Please subscribe the channel and let me know your comments and feedback. Thank you.